So how's everybody? How's your break? I unfortunately only really got to play it yesterday because I only got back. I left. I drove down to Georgia the Friday before spring break, and then so basically the day after our last class, and then that meant I was away from my computer, and my laptop unfortunately just felt like I was playing a completely different game with the graphics all the way turned down like that. So I had to wait until I got home to enjoy its full glory. And by wait until I got home, Sunday was was rough because not only did I drive back, but like my cats decided to discover a way to get into the attic crawl space and decided that it was an insulation playground. So got to spend 2.5 hours on Sunday evening looking for all of them. It's fun. Cats are great, aren't they? Regardless. All right, so you have a quiz due tonight. Just as a reminder, quiz 3 is due tonight. It's not in the same format, but it does have the same hard deadline. Okay, so make sure it's done by 11. Now, with regards to, and so I just want to take a moment to talk about the rest of the semester, okay, and the way I want to try to do this, because I want to make sure that I'm not like overstressing or burning everybody out or moving too fast, while still being able to do our, oh, this is data structures. That, of course, that's going to stress you out. Without like necessarily, messing up with stuff. So I have our due date set up, and I believe they're on a good schedule for this. So currently, what we have here is, let's see, I can unpublish this because it's not necessary at the moment. So I've got the due date set up for our final project, which I'll be discussing in the coming weeks. It's not something you have to worry about yet. Even literally the first thing in our final project is brainstorming, where you should finally start worrying about what the final project is, which is April 1st. Okay, so don't really worry about it too much until April. Your final project is due April 25th, Monday, which is the last day of class, because that is the last day I am allowed to accept late submissions. Okay, make sense to everybody? So it's due on the last day of class because that I literally cannot push it back any further than that. It has a late penalty, right, as described in the syllabus of every minute late is a 10th a point off. So if you need an extra hour on it, but really it shouldn't come down to that, okay? There are going to be 4 parts to it: a progress report, a proposal, and a pre-proposal. So by April 1st, I want you to have a so this is my tentative date for the pre-proposal. Basically, that's when I want you to turn in a brainstorming session and kind of identify people you want to work with. This can be a group project. It's optionally one. If you want to work by yourself, you can. If you don't want to work by yourself, then you can work into a group of up to 3 people. Okay. And then the idea here is that basically you're uploading a form onto GitHub, which will be the subject of a lecture. Your project will be hosted on GitHub. If you have no idea what that means, don't worry, I'll get into that when we get to that point. I just figure it's also a good time to discuss this now, since we're like literally halfway through the semester and we just had a break. So that means that basically all of April in terms of homework is devoted towards the final project. I won't be giving you any additional assignments or runestone reading assignments after this, okay? After April. So April 6th is when I will be submitting is when I want you to submit a proposal. In other words, say, hey, this is what my group and I are going to work on. And there's going to be more details onto that, although if you want to skip ahead and take a look, you can. Okay, but that's basically what you're going to say you're going to want to work on. Okay. The progress report, which is due a week before the final project, which basically tells me whether or not your proposal was, which basically is going to take one of two things. Yes, everything is going great. Or, oh God, everything's on fire and everything went wrong and I can't do what I needed to do, right? That's what the progress report essentially is. And then turning in the final project, which you'll turn in your source code and a recording of kind of a walkthrough, not, and I'm talking like 5 minutes of material here, not 3 to 5 minutes at most. Okay. So generally, now, if this has got you worried, I will come up with some kind of rubric, but in general, if it amuses me for a minute, this is the rubric I tell our TAs. If it amuses you for a minute, that's an A. Okay. So that's like if somebody's making a game and it's amusing for a minute, awesome. If it makes a positive impact on the world in some small way, awesome. You know, so my rubrics are pretty loose, but basically, so long as you try something, and that's part of the point of the proposal, so that we can check off that and make sure what you're doing isn't too difficult or too easy, right? As long as it is good, you know, then yeah, you want to make some weird Wordle clone? Sure, that's probably an A-worthy project. So there is only 2 ways to instantly fail this project. One is to copy paste somebody else's, to plagiarize, essentially. And by plagiarize, I mean like there's kind of 2 aspects to that. One is that basically you just reproduce somebody else's code tutorial without actually adding anything else, right? Or just simply copying, pasting, and not even telling me. That's more important. The second one, copying, pasting a code, which saying, oh yeah, I totally did this. I didn't just grab this off some random website online. And the other way to instantly fail is to basically drop off the face of the earth on it, which is if you somehow did not submit your lab proposal, and I put this in the syllabus, if you did not submit your lab proposal by the progress report, right? So your lab proposal is due April 6th. But if you haven't turned that in by the 18th, you don't have any time left. Instant fail on the final project. Make sense? Right? Because, and this is because for the past couple semesters, I always get one student who emails me the day after it's due or the day of asking for an extension on the final project. And I check and they didn't turn in a proposal or progress report. Right? So they're trying to come up with the final project on the last day that it's due, which is not fair at all to everybody else who's been playing by the rules. Okay, and honestly, they can't have an extension. I'm not going to give it to them. It wouldn't be fair. The only reason I'm going to give you an extension is because you were talking to me about issues that were happening earlier, right? But if you're telling me about like something 3 hours before the deadline, which has literally happened, I'm not helping you there. Sorry. 3 weeks, sure. An emergency issue coming up 3 days, maybe, sure. Now, also worth noting is module 11 is you'll notice that there's a bunch of 0-point assignments here. Those are extra credit. And not only that, they are excellent starting points for a final project if you have no idea what to do. Okay. And they've got 3 kind of tracks: games, mobile development, or web programming. And none of them are in Python because guess what? Once you learn one language, it's not too hard to pick another one up. You're allowed to do the final project in whatever language or technology you choose. So games talks about how to do it, how to make games in Lua, which is a very popular programming language for some kind of games related stuff. Mobile talks about, well, if you're doing Android, that's going to be Java. And if you're doing iOS, that's going to be Swift or Objective-C, I think. Objective-C, probably. I don't use iPhone stuff. And then finally, web development, that's HTML, CSS. And then there's a bit of Python in there, as well as JavaScript. So, but they kind of show you how to kind of build up stuff. All right. Now moving forward, let's see. Currently I have Hurricane Tracker, which is kind of the capstone, like midway. Oh, I can actually do stuff assignment. I have that due next week. It is much, but how many people have realistically like started on it already? All right, not too many people. Hurricane Tracker. Yeah, okay, so some people. So I would get started on it sooner rather than later, but let me know about people's progress in it, because this one is one that looks hard, but once you got it going, it's actually fairly straightforward. Okay. So we basically have 3 more assignments that before the final project: Hurricane Tracker, Hawaiian pronunciation, which will go over dictionaries. And I'm going to be covering, and technically we're in module 8 right now, but I want to just make sure that, like, if I'm going too fast, I can slow down a bit. And then finally, module 9, which is Monte Carlo approximations and cheating at statistics. Now, module 9 doesn't actually have any runestone stuff associated with it, I don't think. And nor does it have any lectures. You'll notice that there's actually different lectures that I grabbed from online and an article. I'll be posting quizzes in the upcoming weeks, quiz 4 and 5 on the upcoming weeks. Quiz 4 will be on files. Quiz 6 will be on dictionaries, which is module 8. And then quiz 6 will be on Monte Carlo approximations, which sound really tough, but they're really not. They're let's simulate something a bunch of times kind of stuff. PIG is the last big assignment. I found that people need a lot more help on that one, so I plan on doing some parts of that in class, in lecture, because people have trouble with had trouble with that one last semester. I should also warn you that that one is the one that people decided to plagiarize on last semester, and I submitted 28 separate charges of academic misconduct for that assignment from people who decided to get it from Chegg. So, you know, just throwing that out there. All right, so do I want the PIG labs in a separate file? You can do that however you want. You can split it up where it makes sense. All right, so with that, before we move on to dictionaries though, I do want you to try to watch this, my videos on dictionaries before, or read it before next lecture on Thursday. But for right now, I want to talk about, we're going to continue working with files, which is especially good since we have been, since we've been away for about a week. So, you know, you might have been, it's amazing what you can forget in a week. Or week and a half, you know, because it was last Thursday that we were here. So, but again, if people need more time on stuff and need me to slow down, let me know. I can always adjust the due dates, make things that were extra credit instead, okay? So, module 8 is, so if you go to module 8 and you click on the Tuesday, that should bring you to one of the projects down here. Specifically, it should bring you to this project, which is exploring common words and SETI. And we're going to just focus on the exploring common words stuff for this part. Let me go ahead and drop it in chat. Oh, a last thing. You may have noticed a bunch of zeros popped up in your undemoed assignments. That doesn't mean it's too late to demo them. That just means that I had to put out undergraduate progress reports. And I'm normally very aggressive about that. Yes. Even though you submitted them. Send me an email. Okay, I will try to track down those emails. I'm sorry. Yeah, probably if it's an issue with you, I mean, you have grades on Runestone. Yeah, Runestone has grades. They're all like 9. Okay, in that case, don't worry about it. Yeah, then that's just simply the merge process, not. Sorry about that. Okay. All right. So anyway, exploring common words and setting. So the idea here is that not all words are equal. Some words get used a whole lot more than other words, right? Right. And it's easy for us to figure out like alphabetically like what word comes first and which word, in the dictionary and stuff, but we don't really have an easy way to like map out which words come, which words are the more the most frequent ones. But the way we would figure that out is that you grab a bunch of text. Okay, you grab a bunch of text and you analyze it and you count all those words. You count how often each word occurs. All right. And there's a linguistic relationship called Zipf's law, which is that words are not distributed evenly. You get a few words that are very common, like and the, right? Those words appear very often. But you don't, but some words that don't appear very often, unless you're in a specific domain, like algorithm or femur, or some other kind of domain name thing. So, and then they point out it's that if you plot this in a log scale, where basically the log, which is a type of way where basically you put the x-axis and the y-axis on a log scale, you get a slope of -1, which will show you kind of just that things are the most frequent words are very frequent and the least frequent words are very infrequent. So we're going to look at these kind of answers. What are the 10 most commonly used words? How does the frequency usage of the most common words compare to the least? What is the percentage of usage of the top 25 most common words? And then we might try a bit of graphing, even though I basically very rarely do that, but I can try it, sure. All right. So what we've got here is that we've got some data set here. All right, there's a word frequency project that grabbed 450 million words from magazines, newspapers, works of fiction, and academic writing, and then basically they published the results showing how often stuff was used. And so they grabbed a small subset of this. Words 5000.csv. So this file is already loaded into the browser. So there's no need for you to import it. It's already there. There's no need for you to download this. It's already there. Watch, open. And this is one of the things I do love about Runestone. And despite all the headaches with regards to grading, I still use it, which is that I can grab this, open this file, right, in a read-only format. Sorry, in a read format. And I'll call it data is equal to this and run it. And you notice that it doesn't give me a file not found exception. I'll just call it done. I'm just showing off right now. Done. See, okay, so this reads it. So let's take a look at what this file is, okay, before we start asking questions, before we start working at it. Okay, so it's got rank, word, part of speech, frequency, and dispersion. Okay, so rank meaning is it the most where it is in the rankings of most common words to the least common. Now these are only the first 5,000. But rank, word, part of speech, and then it's got a code here, like A is an article. The frequency, how many times it showed up. So A in the amount of text they analyzed showed up 22 million times. And then dispersion, let's see. Oh yeah, dispersion is basically, right, how how common it was used, in what percentage of stuff it was used in. So the closer it is to 0, the rarer that word is, or the more specific, I should say, that word is to different contexts. So for instance, whereas is a very common word specifically in, like, kind of legal writing, whereas you wouldn't really hear it so much except when I'm speaking, I guess. Okay, so, or subsection, or just kind of, there are certain, right, you can think about how the legal system has specific words that are used to it, that have specific words for it. So here we have the, be, and, of, in, to, have, to, if. So to appears twice, because it's different things, where we have to, the infinitive to, and we have let's see, 9, which is the preposition to. So I went to the market versus to be or not to be. And they care about those. I'm getting a phone call. Okay, it's probably spam. All right. As a bonus, I ran across this XKCD that many of you on liberal arts campuses may enjoy. The frequency of the word sustainable in the usage in English text by year. So this is a log scale graph on the y-axis. So present day, basically, it's showing that sustainable occurs quite a bit. Then by 2060, a sustainable will occur on average once per page. By 2061, sustainable is once per sentence. And then by 2109, the sentences are all just the word sustainable over and over and over again, which is why you don't want to make projections of random bits of data, because. All right, so the idea here is, so our first task is to read this file and then store the contents into 5 lists. Remember, as you read each line of the file, the line will be represented as a string. Your goal is to split the line into 5 parts and put those 5 parts into the appropriate list. So what we want to do is that we want to take this data, right, and store it in the appropriate, and split it up. So into rank, word, part of speech, frequency, and dispersion, right? So what we want to do, so I'll go ahead and get you started there. So we'll want rank is equal to, and word is equal to, and then, let's see, what is it? Yeah, part of speech, frequency, which I'll just simply call freak, and then dispersion, which I'll call disp, because that way we can use 4-letter variables for everything. And so the next thing we're going to want to do, and this is my last piece of hint, is that we want to go through and read basically every line. So for line in data, which I'll create as a, actually, let me go ahead and do this. Data is equal to data. Actually, let me call it, sorry, line. I'm going to share this, by the way, so you can reload this. So no need to frantically copy it down. So lines is equal to data dot read lines. Sure that I've got that right. Okay. And let's go ahead and print that just to be sure that it's working. And it should just, and you can see it's a jumble here. Now notice that, again, as I mentioned last time when I was working with Pokemon, this first line contains our legend, which we really don't care about, which we don't want to store. So what we'll want to do is we'll want to iterate over all the lines besides that. So for line in data from 1 to the end. So just everything but that first line. And now you can iterate over that stuff and we can say, hey, we'll want to split it. So I will go ahead and basically let you work on the splitting part for about 5 minutes before I show you how to do that, and then we'll move on to the next portion. Sound good? Okay. So I have shared the code. What you'll want to do is reload it. And okay. Oh, yeah, so I named it, sorry. Yeah, somebody pointed out that correctly. So share code again, my bad. Lines. Or line and lines. Thank you. We're trying to read the file and store the contents of the file into 5 separate lists. Okay. Okay. So for this one, it's fairly straightforward. What we're going to want to do is that we would need to split the line. Line is equal to line dot split. Okay. And we are going to split on commas. And that's going to basically turn the line into a list where we have a string, a string, a string, a string, a string. So we have a list of 5 strings, right? So if I were to print out, and this is a terrible idea to do this right now, but I'm going to do it. Actually, we're just going to do it for the first couple. So that's not a terrible idea. So if you see here, right, I've got, that's what the line split move does. The split function does. Okay, so now that I've got this split done, I can take those individual pieces. So rank dot append line 0. Okay, and that wants to be an int. And then next is the word dot append line 1, because that's what we've got here. And so on and so forth for the rest of them. So it would be, I think I called it part, frequency, and disp. And now 1, 2. Got okay.
You got a W instead of Q.
Awesome. Thank you. I was just testing you. Now,
I'm sorry, so one more question. Does it make a difference if you use the append method or the plus equal? What's like the difference there?
a plus equals, you'd have to turn it into a list in order for the plus equals to work. So you'd have to do plus equals and then that individual item, but it would,
Yeah, that's what I think. So.
it is, if it works, it works. Append is a bit more optimized for this kind of operation though. Okay. Because here you're modifying that original list where you're creating, whereas when you're doing the plus, you're concatenating 2 lists together to create a third new list. And then storing that list. Anyway, so this is also an integer. And then finally, this is a float. So now I can just, let's see, print word 5 rank. Let's see. Yes, it will accept the float with the end with the end of line on the end, and I'm going to, and that's part of the reason I'm testing it now. Word 5 had this amount, so frequency 5 and disp of 5. So that's index 5, which means it's this. This should be rank 5. So this will be the 6th common word because again we're starting counting from 0. So, and the word was in. Okay. So now that we have that data, okay, share code, boom, shared. Gonna go ahead and drop it in chat just in case over here. And zoom it, zoom as well. But I shared it, so if you're here, all you need to do is reload it. All right, so calculate the total usage percentage of the top 10 words in the list. Store this in a variable called the top 10. At the same time, calculate the percentage for bottom 10 words in the list and store that in the bottom 10. You'd be surprised how hard it is to proofread. Actually, you wouldn't, considering I know you all make errors. Yes. That same kind of what? Yeah, that's because we just wanted to do this. The person who wrote this problem wants us to do it as lists, so we're doing it as lists. So, so what we want to do here is calculate the total usage percentage for the top 10 words, right? Store this result in a variable called the top 10. At the same time, calculate the percentage for the bottom 10 words in the list. So I'm going to share the code. You're going to work on this one too, but let me go ahead and kind of explain how do you do that. Well, how do you figure out what the percentage of a word is, the use percentage of each of these words are? Okay, well, you add up all the frequency, right? Here's our frequency. So we've got these frequencies ranging from 22 million to till, which has 5,079 words. So basically you want to add up all these numbers and that will give you the total usage. And of course, the percentage is just the percentage for any single word is just that word divided by the total, this big total giant count, by this big sum. So this divided by the sum of all those numbers will give you the percentage for the first word, but we want it for the first 10. And that will give you top 10. And then a bottom 10 for the other ones. So go ahead and work on that one. All right. And again, I have shared that one with you. And again, all this code is the same starting point that I used for the other ones. Okay, got this. All right, so now what we're going to see, so what we're relying on here is the frequency. And we can actually, so we want, as I mentioned, we want to sum this all up. So first off, you can figure out how many words there are by, doing it the standard way, which is for F in frequency, total words plus equals F. Print total words. I'm just having trouble typing and talking. It's surprisingly difficult. Okay, so save and run, and we'll see that basically that this is the total amount of words that we've added up, which is 329 million. All right, so now we want to calculate the percentage for the top 10. Now, also we can do this in a much shorter way, by the way, by just doing, let me just go ahead and comment this out, by just simply doing sum of frequency. Okay. Now, what we want to do is we'd also want to get we want to figure out what the percentage of the usage of these first 10 words are. The, be, and, of, in, to, have, to, it. So we want to add up all these numbers. The first thing we have to do is grab all those numbers, and we'll do so using a slice. So let me just go ahead and print out that slice for you, right? Print out words 10, comma, freak from the beginning to 10. Oh, not word, sorry, yeah, word. They named them all. Okay, so there's the words I said, the, be, and, of, in, to, have, to, it. And then there's the respective frequencies because they're the first 10. The biggest ones are the first 10. All right, so in other words, we can just simply say top 10 is equal to the sum of frequency, the first 10 words, divided by all the words, and that should give us there. And we got 2.76 and a bit, which according to this is close enough. And now we have to do the same for the bottom 10. So, okay. And so for bottom 10, that's for these last 10 words, by the way, which are till, apology, middle class, kid, plaintiff, naval, pistol, manual, laundry, censor. Okay. So those bottom 10 of the top 5,000, okay, we can just basically use the same equation, except we do it the other way around, where basically we're going to say, hey, from the end, I want, and here's where the negative indices that Python has comes really in handy, right? Because -1 is the last item. -2 is the second to last item. So -10 is the 10th to last item. So this is super useful because that will get us the last 10. And it gives us that these words make up. So first off, what in the world are these values? This is saying that those first 10 words, the to, the be, the, those words make up about 27% of our language. That's what it's saying. 27% of all words you get are those words. A lot of them are articles. I have used a bunch in that sentence. I just used another one right now. You know. Okay, but what about these 10 more, these words over here? They make up not 1%, not 0.1%, but let's see, so that is, yeah, not 0.1%, but 100.5% of all the words used. Okay, so these words don't show up that much. And this kind of relationship is, you know, is disparate. This is what this kind of thing is. And it's hard to kind of understand like what we see this difference. It's displaying this kind of data is hard. I was talking about this earlier, kind of in like how you can visualize 7 in your head, except that you might visualize it as the composite of 2 numbers, a 4 and a 3, or a 5 and a 2. Whereas you can visualize 5, or you can visualize 2. You might, once you get to 10 or 11, you start visualizing that as composites. Humans have limitations in the way we can view numbers, right? We just can't, when we're talking about the numbers of atoms inside of something, we have to use scientific notation, and they're just numbers. We don't really have a way of thinking of them, okay? And I like this other XKCD comic. Science tip: log scales are for quitters who can't just find enough paper to make their point properly. Fuel energy density in megajoules per kilogram. In other words, how much energy you can squeeze out of a kilogram of material. Sugar, coal, fat, gasoline, 46 megajoules. Uranium, right? So uranium dwarfs everything else is the kind of the point of this one. Right? And the idea here is that if you're trying to graph this in a way that makes sense, it doesn't make sense really to use this normal scale, because these things are just little, wouldn't even register as pixels if it was scaled down, right? So displaying information is actually kind of a hard thing. And what he's talking about there is log scales, which is basically how do you get things to kind of, you know, show up on the scale together in a way that we graph them. Log scales are used quite often. One of the most famous log scales is the Richter scale. You're basically a point on the Richter scale. Each point on the Richter scale is basically means that the earthquake was 10 times as strong as the previous. So an 8 is 10 times as strong as a 7, I believe. Am I right about that? Or am I just completely misremembering? Anyway, what physicists and other scientists get really excited about is when data such as our observations turn out in the wild turn out to be a straight line in some way. So what I'm going to do is I'm going to load this from last semester, because graphing is sometimes a bit of a pain to do this. So change course for a second. Change course to fall. Scroll down to this project, because trying to relearn how to do this on the fly is always kind of an embarrassing thing. And there's a lot of different cool graphing things you can do in there's a lot of fun kind of graphing things you can do in Python. There's different graph libraries that are just good for producing native graphs that just kind of appear. Well, the most common is matplotlib, which is famous, and you can find various tutorials on how to do that. Let me log back into this course, reload this page. The one they use here is Altair, because I think it embeds really well on the web page. So here I'll go ahead and paste the code, share it. Let me run it, make sure it still works, share it, and I'll run you through, and I'll walk you through it. Okay. So shared the code. So what we've done here is that we've imported two things. We've imported Altair, which is their graphing library, and math. Okay. And then last semester, as you can see, I used basically the same variables. And instead of putting it in lines, I just simply did data read data lines, and then I did it exactly like this. So interesting that I did the 10 there. Okay, what happens if I leave out this 10? I'm just curious. Or was I talking? Yeah, nothing. Okay, great. So let me just, and I'm just experimenting one more thing. Update. X is equal to rankings. Yeah, okay, great. So I did not mess anything up when I was messing with it. Great. So the graphing is fairly straightforward on how to do it. What we've got over here is, let's go ahead and remove this log first off, because we don't need, aha, that's what that was for. All right, so what I'm gonna do to start off with is graph this data. And this is the graph we get. Okay, how in the world did I graph this? So first off, let's look at our graphing. We've got an XY axis over here, okay, where it has a frequency and a ranking. So the ranking is the rank of the word, right, from 1 to 5,000, because each number is 1 to 5,000. And then the frequency is how often it appears. And as we can see, it looks kind of like, we're outlining the graph, right? That's right, we're outlining the axes, because it's all the way up here in 20 million. That's where our first word is. And it quickly plummets to being small. So this is just simply graphing it, graphing it. And it doesn't really show us that much of a strong relationship. It doesn't really show us too much. We can't, this just gives us, okay, a bunch of words, all this shows us is that a bunch of words have a, this kind of strong comparison over here. So some word, the most popular words just appear a whole bunch. And these don't appear at all, really. So what it's saying over here is, what we can do is that take the log of the frequency and the log of the rank to do this. Okay. So what we're going to do is we're going to turn this into what's called a log-log scale, where basically we take the logarithm of each of these things. And that just kind of shrinks it into powers of 10 over here. So what we're going to do over here is that so actually, before I go on, let's talk about how I made the graph. What I did is I overwrote data and created and used basically and said, hey, the Altair graph, I'm going to use the Altair package. And here's what the data is going to be. We're going to have a ranking, an axis called ranking, and an axis called frequency. Okay. And then we're saying ranking is going to be equal to the variable called rank, which is this one, the list of all the. So ranking is going to be all the values in rank, and frequency is going to be all the values in freak. I'd like you to make a chart of this. That's what this line does. And I'd like the data to be presented with using a line rather than like just dots all over the place. And then how do you want the line to go? I'd like to encode those with X being the ranking and Y being the frequency. And that's what it did. And then I said display to actually display it. There's an entire module if you want to learn how to do this, but generally it's just with things like this. A lot of what you'll find in coding is you'll remember a lot of the basics, but for edge cases like how to do graphs, unless you're doing it frequently, you'll like learn about it and then you'll have to reference it later. Like the amount of times that I would have to just make sure I retaught myself like matrix multiplication because I didn't have to use it for an entire semester, right? It's kind of like that. Except I don't think most people forget matrix multiplication. So, but the point being is that, you know, once you've learned it once, it takes about like 10 minutes to refresh yourself. So now what we're going to do is we're going to change these values to be log mixed. So if I do this and math.log, and what kind of logarithm do I want is kind of what it's asking here. So 1, 2, 1. So I've got an open, and a close. There we go. Math.append 1, 2, 3, 1. Sorry, it was counting. I'm counting my parentheses because it's not highlighting my parentheses for me. So what I'm doing is I'm appending log base 10. And now, again, math.log and yeah, sometimes it's just a pain to line up those parentheses. And by the way, this should give you an idea as to why long one-liners are not a good idea, like I'm just doing here. Save and run. And you'll see something that looks much more like a straight line, especially for those later values. We see kind of a linear decrease. And what we see here is basically that we're kind of getting a very constant kind of decrease in the word usage. That words are basically, so what is this rank, by the way, over here? This is 10 to the second power, 10 to the fourth power, 10 to the sixth power. So this is still like and over here is in our 7 millions. And what it's saying over here is that we've got a bunch of words that are in the millions. And then the words over here, so we've got a small amount of words in the millions. Then we've got so like 10 words in the millions. Then we've got 100 or so words over here that are between 10 to the fourth and 10 to the sixth. And then these 1,000 words over here are that only occur 10 to the fourth or 10 to the sixth. So they occur hundreds of thousands of times or thousands of times. And then the vast majority of words, which is right, so this is all the words in the thousands place from rank 1,000 and up, they're occurring basically very infrequently in comparison. Does that make sense? So basically it's saying, so let me go ahead and annotate because log can be a bit weird to read. Basically, these guys don't appear that much. Sorry, these guys, there's only about, right? This is from rank 0 to 1. That is from 10 to the 0th power, which is 1, to 10 to the first power, which is 10. Then 10 to the 100th power, which is, 10 to the second power, which is 100. So we've got basically 90 people in here. And we've got, so we've got 90 different words in there. And here we've got about 900 different words. So what we're seeing here is that basically that, and we see that basically with this is very squiggly, whereas this kind of has actually looks like a brushed line. So that's, and I find that interesting. That's basically following a slope. And when you can slope it, it's pretty good. All right. So for our last exercise, and I'll share that right now. For our last exercise, which I find to be more relevant for us, we can probably come up with some interesting questions about this list of popular words, but let's go ahead and just work on this one over here. Which of the words, when spelled forward, are also on the list when spelled backwards. So for instance, pot is one of the most common words. And when you spell pot backwards, you also get top. So the question is the same word spelled forward also spelled backwards on the list? So let's go ahead and load history. And I'll let you work on that for the last bit of class. And I've shared the code there. So what words are spelled backwards? So how do we do that one? Well, we're going to iterate through the list of words, right? And for each word, we can ask, is that word in reverse in the list by using the in keyword and an if statement. But how do I reverse a word? So let me just go ahead and show you very quickly how to the easiest way to reverse a word to figure out, okay, which is fairly simple. So word is equal to, let's go with wolf. One of my favorite words to spell backwards is wolf and flow. So word is equal to word. And this is a little hack in Python. That means reversed in Python. That's the easiest way to reverse something, where you slice it from the beginning to the end, right? So from beginning to the end, but then you have the third argument, which is what increment do you want? -1. So I'd like to go from backwards. So if you want to reverse a word, all you have to do is just take whatever it is, and this will reverse any word or any list that you have. It's pretty useful. Okay. So let's just take a look. We'll look at this, words that are on the list that are spelled forward as well as spelled backwards. All right, so this line up through line 15 is us reading the list. So for W in word, because our list is called word. All right, so reversed, oh, apparently that's a key. Reverse is W, so that. If reverse in word, then we want to add it to, then basically we'll go ahead and print out word. That's all we really need to do, I believe. Whoops. Ooh. Oh. Yep. I see. That was my mistake. I printed out the entire, I meant to print out W. And instead, I ended up printing out the entire list. So if I reverse in word, and we've got A, because A, of course, is reversed. I, on, no, on, part, live, level, I. So some of these words that are appearing are palindromes, right? So that'd be a bit trickier to figure out. Ha and ah, radar, level, part, pat, trap, tide, civic, net, pop, tip, pit, wow, noon. All right. It's 3:15, and I think this is a perfectly good stopping point for this one. So I will go ahead and share this. On Tuesday, so on Thursday, let's see, our exercise will go over converting Roman numerals unless people need some extra help first. Or I can just give a much more thorough lecture on dictionaries and those kind of things. What was that? Oh. Let me stop. When are we going over GitHub? We'll go over GitHub closer in a couple weeks, in a couple weeks.